Hi guys, sorry, I apologize for that interruption. What we were just saying is we're finding that length, HJ, that entire side of the triangle, and that this is the third time we've seen this particular idea come back, and that is the segment addition postulate. I know that that side, HJ, is going to be equal to the sum of the segments that make it up, which are going to be HL and LJ. Fortunately, I know what those are. If HL is 63, and this is a perpendicular bisector, by definition, it splits that side in half, so LJ also has to be 63. That means if HJ is equal to the sum of those, we'll have 63 plus 63, and if my math serves me correctly, we'll wind up HJ being a length of 126, 63 plus 63. Great, let's keep going. I got one more for you here. I want to know what is the length of ZJ. All right, that is ZJ is the distance from that circumcenter to a vertice, but I know that that distance is the same for all of them. Let me write all of this out. ZJ is congruent to ZG is congruent to ZH. If I know even one of those lengths, I know all of them, because that's the definition of a circumcenter. It's equidistant from each of the vertices. That means that ZJ is equal to 65, since I already knew the distance from Z to G. All right? Hey, let's head on over to the next page of the notes. I got a couple more really great ones for you here. What we're going to actually do with these ones is I have given you some points. We're going to plot the points, draw the triangle, and then I want you to find that circumcenter. Find the circumcenter of the triangle. Let's start by plotting these points. So here we go. First point is going to be R. That's negative 6, 0. Negative 6, 0, I believe, is going to be that point right there. We'll go ahead and call that R. There's point R. S, 0, 4, 0, up 4. 1, 2, 3, 4, right there. Call that one point S. And then my last one is at 0, 0. That is my origin right there, where that's going to be point O. And hey, let's go ahead and draw that triangle in right there. Okay, now remember, the circumcenter is going to be the point of concurrency. That means the intersection of 3 perpendicular bisectors. However, you don't have to draw all 3. It turns out that drawing 2 of them is actually enough. As long as you have drawn actual perpendicular bisectors, wherever 2 of them meet, you know that the third one would meet at the exact same point. So we're going to draw 2 perpendicular bisectors, and we're going to pick the easiest 2. I have 3 sides of a triangle, which means there's 3 perpendicular bisectors. But on this particular problem, 2 of them are going to be pretty easy to draw. Perpendicular bisectors have to be 90 degrees, and they have to split the sides of the triangle right in half. Well, that's why I put it on a coordinate plane for you. 2 of these sides of the triangles you can just count. Divided by 2, and you've got the midpoint. Let me show you. Do it in green. This side of the triangle right here, RO. 1, 2, 3, 4, 5. It's 6 units long. What's halfway? 3. So 1, 2, 3, right there is the midpoint. That is halfway between R and O. And how do I draw a perpendicular line? Well, RO is horizontal. So perpendicular, vertical. There's my perpendicular bisector, and I'll put the little right angle symbol in there for you, just so that you know. Perpendicular bisector of RO. I got one. Let's get another one. Ooh, look at that. OS is going to be another easy one. Count it out. 1, 2, 3. It's 4 units from O to S. 4 units. What's halfway? Look at you guys doing good math. It's 2. So my bisector is going to be right there at 0, 2. Since OS is a vertical line, a perpendicular line will be horizontal. So we're going to draw a horizontal line. This is my perpendicular bisector. Put the little right angle symbol in there so that you know it's a perpendicular bisector. But remember, what we're looking for is the point of intersection of those perpendicular bisectors. I think we found it. Right there. So what I just did is I have now found my circumcenter. This is my circumcenter. It is the point where my perpendicular bisectors intersect. What is interesting about this is because this is a right triangle, your circumcenter lies on the hypotenuse and is at exactly the center point of your hypotenuse. From R to S, that guy right there is the midpoint. It's exactly halfway between R and S. So since I asked you to find, right, what did I ask you to do? I asked you to, find the circumcenter. Well, we did. We'll call it P, and it is at 1, 2, negative 3, 1, 2. Negative 3, 2. Found your circumcenter. Hey, I think I got another one of these for you to try. Let's take a quick look at it. Take a peek. Here we go. Once again, I'll need you to go ahead and first plot the points. Then I ask you to find the circumcenter. We only have to write 2. 2 perpendicular bisectors is good enough as long as you've drawn them accurately. Wherever they intersect, you can be confident the third will intersect there as well. A point of concurrency requires 3 or more lines, but we can kind of fudge it on some of these problems. You really only need 2. Find the point where 2 of them intersect. That will be where the third one intersects, as long as you've done it correctly. So here we go. Negative 1, negative 5. Negative 1, 1, 2, 3, 4, 5. Right there, that's going to be point A. B, 5, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's B. C is at 5, negative 1. 5, negative 1. Right there, that's going to be point C. Great. There's my triangle. Now again, I'm trying to find the point of concurrency that gives me the circumcenter. That means I need perpendicular bisectors. Once again, I put it on a coordinate plane to make it as easy as possible. Just count, right? So 1, 2, 3, 4, 5, 6 units from A to B. Halfway is 3. There it is right there. Draw that perpendicular bisector. Put that little right angle symbol in there so that I know it's a perpendicular bisector. Great, do BC. 1, 2, 3, 4, 5. It also is 6. Means halfway is 3. Perpendicular bisector. Put my little right angle symbol in there, and the point where they intersect is right there. Once again, no surprise, this is a right triangle, which means the circumcenter will fall on the hypotenuse, and it'll be exactly halfway between A and C on the hypotenuse. That's all I asked you to do. I just wanted you to find it. So that circumcenter, which we'll call point P, why not, is going to be at positive 2, positive 2. Now, quick question for you. I made these ones fairly easy, but let's say I did decide to give you a tricky one. And I gave you lines that were all at an angle, that weren't horizontal or vertical, right? A, B is a horizontal line, B, C is a vertical line. You can just simply count to find the middle. But what if I gave you a triangle where all of the lines were at a diagonal, like AC? How would you find the midpoint if you weren't able to count? All you'd have to do is use the midpoint formula, which is x1 plus x2 divided by 2, comma, y1 plus y2 all divided by 2. What that's going to do, right, you take your 2 points, A and C. You know the coordinates for those points. Assign an x1, y1, an x2, and a y2. Plug and chug into the midpoint formula. Don't fat finger something on your calculator, and it will give you the midpoint, which you need to draw a perpendicular bisector. You need that midpoint, and then you draw a perpendicular line to that point. So if I were to give you a trickier one where all the lines are on a diagonal and you can't just simply count, whatever, again, back in chapter 1, we talked about the midpoint formula, and you could simply use that. Guys, that takes care of everything for this set of notes as far as finding a circumcenter, how do you find it, and then ways that we can solve problems using that property of a circumcenter. Thanks so much for joining me. I look forward to seeing you next time. Bye.